Today, actually, I'm here to talk about data processing today. Thank you all for braving data processing as the last talk of PyCon before the lightning talks. I'm going to try and be engaging enough to not put you all to sleep. And if you do know a little bit about SQLAlchemy or Celery already, I'll try and shout at the big junctures to wake you up for the next section of things. So I'm Roger Barnes. You can find me on Twitter, email, and I will put my slides on SlideShare after today. So I'm going to talk a bit about data warehousing and data integration. And I realize looking at the program today in particular, there's a lot of people who do data, a lot more than I do. In terms of big data and analytics, I'm not going to try and cover a lot of that sort of stuff. What I'm really looking at is a framework for doing data processing within a smaller environment. It's not to say you couldn't scale this stuff up, but this is really talking about an experience I had with taking sort of disparate systems and munging the data together using a pure Python sort of framework. So to do that, we're going to look at a bit of SQLAlchemy and also Celery, which is sort of an unlikely contender here, and how I've used that. So I've been doing software development and other things for quite a while now, and I spent 11 years at a business intelligence vendor. While I wasn't directly involved with the software they produced, I certainly cut my teeth on a lot of these kind of concepts at the time. I'm currently contracting, and this particular talk is actually about a specific reporting system that I've built for one of those contracts. So first of all, for those who aren't familiar, a bit of an introduction to the idea of data warehousing or data integration. Because there are lots of different systems in an organization, you might have different data quality levels, different data life cycles, different departments collecting and doing different things on all sorts of different levels. What that means is you end up with a very disparate set of non-heterogeneous data, and it's also potentially used in different ways, which is ambiguous and not actually consistent across an organization. What we really want is some sort of centralized reporting that is timely, that is accurate, unambiguous, complete, and ideally isn't impacting production systems. A lot of this is about making sure that you don't have the Excel empire out there where Bob in marketing and Jane, the IT director, aren't getting their little bit of data from their little spot, and they might be hitting the systems too hard, or they might be getting it completely wrong and actually reporting on data that they thought was accurate or complete when they're not getting the right information at all. So looking at a data warehouse, I'm sort of, at a top level, it really is just a central repository of data that integrates all of these disparate systems together. Beneath all of that, there's a huge amount of theory and really good practices in data warehousing that I'm not going to go into today. But that concept of basically integrating everything together is what I'm going to focus on. This particular slide isn't designed to be readable, so I'm not going to apologize for it yet. This is a slide from the School of Data. It basically shows the different skill sets involved in what's it called? Data processing pipeline. And basically there's a very large range of things, from understanding data, analyzing it, even things like governance and compliance and so on. What I'm actually going to focus on is really that middle bit of this diagram, which is about the extraction and transformation of data. Or in other words, this is a bit of a nicer diagram, I think. Extracting from multiple systems, transforming that through a staging layer, and then putting it into a central database for consumption. So, we're all here for PyCon. Python can help do this. It's really good. I think I'm probably preaching to the converted here. Really good for rapid prototyping. Lots of potential for code reuse. There are a ton of libraries out there. So whether you're parsing XML or scraping web pages, reading CSV files, or reading out of databases, there's likely a library out there or some way to get to that data. Finally, Python's quite good for decoupling. So actually keeping your flow, the data flow that you're dealing with under management, doesn't have to be tied to the actual processing, and the business logic doesn't have to be in the same place as well. So good design allows you to separate those three concerns quite well. In terms of existing solutions, I sort of did a survey of this before I embarked on this project, and there's not a whole lot in the Python space around any business intelligence. There are some things out there, and I'm happy to hear about more of them if I've missed any. People do tend to roll their own, and quite often that's because the business problem is often quite different, and often the domain or the scale or the shape of the data really informs what decision you might make about a solution. There is recently released a framework called Bubbles or Brewery 2. Databrewery.org is where you can find that. There is a link in a resource slide at the end. It's basically a framework that lets you build up operations and patterns that you can string together in a pipeline. So it's not unlike what I'm going to talk about. I haven't dug very deeply into it though, so I can't really give you a comparison at this point. I'm going to talk quickly about ways to move data around. Often the source data you have no choice about, but once you have your data, you could be looking at things like flat files, be it CSV, XML, or what have you. There's a whole lot of NoSQL data stores around, and depending on your data, they could be quite useful. And of course, you've got your good old relational database systems. And what most traditional data warehouses, and this is certainly an area that's changing, tend to lean on these systems. I'm going to talk about SQLAlchemy today. But really going back to that whole concept of decoupling, you could use some of the concepts from this framework and build something based on a NoSQL solution. It's really about sort of gluing together some concepts here today. So very quickly, I'm going to talk about what SQLAlchemy is. Just quickly, who is familiar with SQLAlchemy at all? Who thinks they've used it enough to be regularly familiar? Okay, that's good. There's a few people. Maybe I can convince you that it's worth looking at. Basically, SQLAlchemy is a Python SQL toolkit in one layer and an object relational mapper on top of that. What that basically means is that you can generate SQL for various databases in a declarative sense using Python. We're actually not going to look at the object relational mapper today because with this sort of low-level data processing, it's not something where objects and relational mapping really will help you out. You can perhaps fall back to that, and SQLAlchemy does let you sort of jump back and forth between them if you want to. So if you do need that for perhaps being strict about your data definitions and so on, then it's something you can also consider. So SQLAlchemy is fairly well established. I think everyone's heard about it, so I won't go on too much about that. And it's also well used throughout the industry, so you shouldn't have any concerns about using it if you think that it's sort of an under-supported kind of system. It has really good database support. There's probably obscure databases out there that people are using that aren't supported, so it's certainly worth checking, but it's got the basics pretty well covered. And it's also got good Python support. So again, depending on your environment, there's lots of options there. SQLAlchemy is something like an onion. It has layers. Basically, at the bottom, we have the Python DB API, and SQLAlchemy just builds it on top of that. It has dialects for dealing with different databases, connection pooling, transaction management, and an SQL expression language and schemas and types, which is really where the heavy lifting happens in terms of translating you're talking about data in Python into SQL that actually pushes and pulls information out of databases, which is what this slide says. So, like I said, the ORM level is somewhat unnecessary when you're doing data flow processing. So we're looking just at the core. It does those bulk operations. You can fine-tune it. Ultimately, this stuff is just generating SQL, and so if you need to, you can dive into lower layers of the SQLAlchemy infrastructure and fiddle with it to make things work better. A really quick example of how SQLAlchemy looks. This is creating a table. Basically, you create an engine, you have some metadata, you then generate that table against that metadata using the engine that you've created. So this is just an in-memory SQLite. You could run that code and you would have a database table. Inserting data is simply a matter of having, in this case, a list of dictionaries, key value pairs, and putting them into the table using an insert operation. What you can even do is say vehicle table.insert down here and actually print that out, and it will give you the string representation that is the SQL that it would run. Finally, you can pull data back out, of course, and again, it's very much a declarative kind of thing where you say, I want a select statement, I have filtration, you can order and group and do all the things that SQL can do. Basically, SQLAlchemy tries to do that across a common set of backends for any imaginable set of functions, and for those that it doesn't cover, you can always generate little bits of manual literal columns and SQL and functions that might be specific to your database. So now we've got SQLAlchemy sort of figured out a little bit. Thinking back to our data processing, there's this idea of going from that extraction stage and through a series of transformations. And every one of those should be encapsulated into a unit of work. So extracting from this CSV file into this table, or extracting from this database to this table, or transforming that will derive a new column in an existing table, could all be considered single operations. And so to that end, we have this idea of a processor. So here's some example possibilities of generic processor types. You might even have report types that are processors as well. And so now we're going to get a bit dirty and we're going to look at some code. This is a base processor and it's really just a shell at this point. If you call dispatch on this processor class, which is an abstract one, it will ultimately call the run method, which we will need to implement in some sort of subclass. The next logical extension of a processor is to have one that actually processes on a database. So here we're subclassing the base processor, and we now need to provide a DB class, and now when the run method gets called, it will set up a session for us that's available for our run method to use. Going slightly sideways for a moment, we have things like mixins where you can actually have, say, a CSV Extract Mixin, which will encapsulate giving you a reader given an input file. And so we can combine these blocks at a class level into things that will extract from a file and put it into a database. I should point out here that these code examples are functional, but they are somewhat simplified from what I've actually ended up with in the project that I work on. There are certainly some additional possibilities here. So here's a concrete example of an extract. It is a CSV Extract Mixin and a database processor. And basically all it does is it uses SQLAlchemy to create a table instance. It then creates columns based on the first row of the data from your CSV file. And then for every row beneath that, it inserts them into the table. It's a very naive but complete example of extracting from a CSV file into a table. And so now what we have is a single processor that can do that one job repeatedly. In this case, it actually tries to create the table as well, so you might need something that either resets it or is conscious of that possibility and needs to decide to do something from there. Thinking ahead a little bit further, there's the concept of transforming data. So you already have a table, and you might want to add an extra column that is computed based on other information already in that table. So here we have the concept of an abstract Derive transform that, given an input table, which is also the target table, some sort of key column that lets you keep track, which columns do you want to select to do your computation, and which target column you're actually promising to provide. We have then this abstract process row where, having selected certain rows out of your table, you will apply a process and they will get written back out to the database. And I'm having to do slide-driven development here where there's a lot of additional code potentially involved in doing that. If anyone does want more code snippets, I'm happy to provide them. It's not something I've actually extracted into an open source form though at this point, so I can't point you straight at it at the moment. So a concrete implementation of a transform might be the Derive foo transform. So we have a sales table, it's keyed by transaction ID. We know we need the location and the username to derive foo, and we're going to write out a target column called foo. And all we have to implement is the process row, which calls upon some external business logic to derive foo based on the location and the username provided. Again, this is quite a simplified example. And it might be that your abstract processor will only update values that aren't already derived. So if you've previously already extracted some information and derived it, this would let you, just update those that need derivation that haven't had it before. Are there any questions at this point? Maybe we actually should save it to the end. It'd be easier. So that's kind of SQLAlchemy, and we've defined these processor units of work that will do jobs that will extract and transform. And at this point, you could run them in an order that you know, and you can get some information out at the other end from a consistent and coherent set of tables. So now let's have a look at Celery. Wake up. We're now looking at Celery, which traditionally is used in web applications, and it's used for back-end processing of things that, a user logs in and you might need to go off and do something like download their Facebook friends, and you don't need to interrupt the user with that, so you do it in the back end. So Celery is a distributed task queue. You can push tasks into the broker, and a bunch of workers will pick them up and do that work. That's pretty much all Celery is. Basically, at its core, Celery has the concept of a task. And so what we have here is a very simple wrapper that takes a Celery task and extends it so that given a processor, which we've just looked at, it will actually run it. So up the top, we have the abstract version of the class. The 2 lines near the bottom are saying the Derive foo task is simply a processor task that runs the Derive foo transform. And then the way that you run a task with Celery, you say Derive foo task.apply async. And so that would get sent off to the Celery broker in the back end to be run. So now we've gotten from the point of a transform that can be run to a task that can be run asynchronously. How can this help us from here? On top of Celery, there is a thing called Canvas. And Canvas basically gives you a way to combine these tasks together. You can create groups, so you can say, I want this task and this task and this task to run, and they don't depend on each other, they can all happen in parallel. But then you might need to say, tasks do depend on each other, and so you have this concept of chains that run in series. And so you can combine series of groups and chains, and there's also things called chords and maps and various things that will build kind of a graph kind of shaped series of dependencies. And this isn't necessarily about getting performance out through parallelization, although that is something you can get. It's more about putting things in an order that you know that this task is going to depend on the output of this task, so run it beforehand. This example here is from the Celery docs. It basically demonstrates that after creating a new user, well, the new user workflow, we'll create a new user, and the pipe here is actually going to create a chain, and it pipes that into a group, which is in parallel, importing the contacts and sending a welcome email. And then again, we're going to then run that workflow given a set of input. So now we're looking at a data processing flow. We've talked a lot about the concept of how this all works now. So this is just one fairly contrived example where you might have different data from different sources, and we sort of group together the extract time concerns. We then have a series of transforms that copy that to a transform layer, so we leave our extract layer alone, and we then start transforming in a separate layer. This gives us some options where if we want to actually blow away that middle layer, we don't have to re-extract everything all over again. Sometimes having multiple copies through the pipeline can give you that flexibility. And we have just one simple transform here that will normalize the currency of your sales data before joining them all together into some reporting structure, and then actually running some aggregations and an exception report that will perhaps look at data quality. So that's the visual representation of that. And these boxes and arrows are effectively groups and chains. The way that looks in code, I hope that's readable, is actually we define 3 flows: an extract flow, which is one group, a transform flow, which is another group that also happens to contain a couple of chains, and then a load flow, which is the quality task and our aggregation tasks. And then our all flow is the chaining of all 3 of those subflows together. The process of running that would then simply be a matter of all flow.apply async. So once you've done that, you've sent off all these tasks, and they're sitting in the broker and sort of ticking over, and the workers are picking them up, and things can go wrong and so on. We need to think about ways that we can actually monitor this and see how it's going. So Celery has within it an events view, which is a simple cursors-based interface, and it's actually, I've had to blank some things out in there, so that's what the gaps mean. You can actually see how this flow is running, and you can see where there are chords that are waiting to unlock because there are processes in action. You can see that one of the transforms has started and some others have already finished. So as this process is flowing, as soon as you've kicked it off, you can look at this view and see how things are ticking over. You can also navigate in and look at the results of each of these. I didn't point out specifically before that each of your tasks can return a value. In the example, I just returned the row count, but you can also return, for example, a dictionary containing multiple bits of information, maybe some messages, some kind of metadata about how things are going. There's another view into things which is more modern, but for this sort of processing I found was less real-time because it doesn't refresh as often, called Flower. And this gives you a web-based view of much the same thing. So as I said before, this is really a simple example. Turning it up to 11, you can add all sorts of things to this infrastructure. I've added a requires and a depends structure to this where each task says what it provides and says what it needs to do that. And so there's a unit test that once you've defined a flow, asserts that every task in the pipeline actually gets provided what it needs upstream and provides to the things downstream that it's supposed to. Doing things like incremental data loads lets you, rather than doing en masse replacements through your data flow, you could look for, say, just the last 24 hours of data and not reload everything over and over again. This has a lot of potential to speed up processing time where you're just loading the new data, you're just processing the new data, you're just reporting, or perhaps you have to rebuild the reports at the end because of aggregations. But it certainly can speed things up. This particular reporting system took a process that, for whatever reason, took 4 hours to run, and now, after an initial run of several minutes, can potentially run in several seconds. You can also potentially parameterize these flows and say, well, I have a nightly run that actually does everything, but maybe every 4 hours I just want to refresh the extracts and rerun the data quality report, which only needs the extracts to have run. You can customize and choose which bits of this you want to do. Tracking flow history, actually storing the results each time that you run your flow, means that you can keep track of, just as you would with any other batch system, knowing historically how things have gone. And of course, with the power of Python, you can hook into just about anything else. If you want to do some fancy natural language processing or scientific computing in your transforms, you certainly could. Really though, this particular system is about getting data in a well enough mangled form or unmangled form to do those analytics in a separate environment. So I'm running quite quickly through this. To summarize, basically we talked about an intro to the concept of data warehousing or data integration, and I've shown a simple example of how one would process data with SQLAlchemy and then string it all together using Celery's canvas. I've got a list of resources here which will go up on SlideShare. And that's actually me done. Any questions?
Hi, thanks for the talk. That was great. I actually do very similar things to what you're doing here at my work. Although my ORM's kind of, I just use the Django one because that's what I knew. And I've thought about whether or not I should go to SQLAlchemy. A good thing with the Django one is I've got South for my migrations. Mm-hmm. What's the quality of SQLAlchemy's kind of migration handling for me? Does anything good exist?
Sorry, was the question the quality of...
Is there any good tools that can do schema migration for me in SQLAlchemy?
Yes, there are two migration tools in SQLAlchemy. One's called SQLAlchemy Migrate, and I believe it's quite functional, but is now sort of unofficially deprecated in favor of one called Alembic, which will do migrations also. It's something I didn't really touch on, and it's a very good question because often your data changes and then your flows need to update accordingly. Some of the things I've done is actually put poor man's migration into these flows where if a new column appears, it will automatically put it through your middle stage layers, and you can expect it to show up on the report at the other end. Now, you might not be comfortable with that, and so then you could look at some more specific migration tools. At the moment, it seems to be working well that this thing is kind of amorphous and it adds columns when it knows it needs to, and then by the time you get to the end, there's a certain amount of also putting testing in place and validation reports at the end to say this number should have come out or this column should have at least come out as well.
Hi, it's nice to see someone talking about SQLAlchemy. It's probably way more powerful than Django's. It's not as expressive, I think. I've used both. And yeah, Olympics pretty fantastic. We use it in production. My question is that you had a very structured way about it. You know, you had your classes and your subclasses, and I was getting a bit of a Java feel. I'm not trying to insult you or anything, but is this because you often do these kind of things, so you've got a very structured way of doing it, or you're just a very structured thinker, or exactly how?
It kind of evolved that way. First of all, you've uncovered my dirty little secret that the 11 years I was at the business intelligence vendor was with Java. But it actually, I started out writing this quite functionally, with functions to do a lot of things. And as soon as I wanted to refactor the common code, I found myself in classes. So I have a mixin for this, and there's mixins for updating blank columns or for selecting rows out of a database. And in some ways, it's probably got a couple more layers than I'd like, and it's time to refactor back down. And perhaps this example shows about us as, you know, it shouldn't get any more subclass than that, really. Once you've got those layers in the top, you then just use them, and then you have a flat structure. So it's not necessarily strictly the case, but what happened in my case is that worked out the best, and the person who I was working with didn't disagree, and he knows some Python too, so yeah, it seemed to work. I'd be open to hearing alternatives to that. I'm not saying it's perfect by any means. Yep.
How do you pass data between each stage in the pipeline? Can you take this through the output of one and pipe it into the next stage? How have you found the best way to do that?
Very good question. You can actually have the tasks receive input and provide output, but for the purposes of these flows, they actually don't take any parameters or produce any result that's consumed by other steps. It's certainly possible, but what we decided in this was that actually we only have one database that actually is the core of all of this warehousing. Once everything's extracted, the rest of the process is the same database. So at that point, we know what tables are in there, and we let the data speak for itself. So in more complicated cases, we actually put timestamps on things, and we say the last modified record or the last modified column even, we actually have per column timestamps, was this time. Let's look back at the columns that feed that and get any data that's newer or refreshed and rerun those. But it's purely the data lives in the database, and the transforms, by virtue of the fact that they know that they have to come one after one another, trust that the last step has put stuff in there. But as I said, it is possible for maybe the upstream process to communicate something to another task to say, hey, you need to know about this. But it's not so much at a streaming data level. It's really pick it up, put it down, pick it up, put it down, in terms of its structure.
Are there any other questions for Roger?
I know that there are a fair few options with Celery for how you actually pass messages around, and I was wondering, RabbitMQ or Redis, and I presume you can use the database itself. Did you actually need to care about that side of things, or was there any particular reason you chose one solution over another?
Not particularly. Because it's really using Celery in such a different way, things like concurrency and how it handles messages and whether you can have different kinds of queues weren't a factor. I've used both Rabbit and Redis, and at one point I was using SQLAlchemy even itself as a back-end broker. And SQLAlchemy wasn't full-featured, so I dropped that simply because I wasn't getting events and sort of broker-level information in the monitoring. But Redis and Rabbit have both been fine. A lot of the decision-making came down to whether some of these ran better on Windows or not. I don't use Windows, but my colleague does, and so sometimes that was a factor, but both actually work just fine.
Anybody else? All right.
Well, Roger, here is a packet of the Norwegian Blue roast of the coffee that was being served through the conference, and here is the conference PyCon AU conference mug. Please join me in thanking Roger Barnes.
Thanks for your time, everyone.